Hi, Hallie. Sorry about the appointment yesterday. I just thought it would be more efficient if we did it this way because I only had about 10 minutes before my next appointment. So the first question here is saying they give you the normal information here. So they're giving us the mean and the standard deviation squared, okay? And so they're just saying this data is normally distributed, and that the mean of our data is 242, and the variance of our data, which is SD squared or sigma squared if it's population, is 29. I think that says 29. I'm going to just make it bigger so I can make sure it's not 2.9. Yeah, okay. So what happens there is that we have to take the square root of that number in order to make it the SD, and it's the SD that we're going to use in our calculation for our z-score. Okay, so the SD is the square root of 29. So when we find the score that's needed to be in the top 25% of students who take the exam, that means that we're looking for a p-score of 0.75 or higher. Because that's the top 25, right? That's 75%. So if we have p equal to 0.75 or higher, then we're in the top 25, or the 75th percentile is another way to look at that. So what we need to do now is go back to the chart. I'm just gonna bring the chart down here. Okay, so here's our z-score chart, same as what we used last year. And so we're going to be on the positive side, or the right-hand side of the mean, if we want the top 25%. And we just have to find the z-score that's as close to 0.7500 as we can get. I know it's a little hard to read because the flash blurred it. I'm looking here and thinking that this one looks good, and this one looks good, 0.7436, and I'm just trying to read what that other one is, 0.7580, sorry, it was this one, not that one. Okay, so 0.7580 or where was that other one? 0.7486. Oh, 0.7517 is here as well. And so that one is 17 one-thousandths away, and 0.7486 is 14 one-thousandths away. So we could choose either one of those values as our 0.75, and so we're actually in the 75th percentile and a little beyond it if we go to this value here. So if we back that up and we look at what z-score that would be, then we're going to go back across in this column for the whole number for the beginning part of it, which is 0.6. And then we're going to go back over here and find the column number, and it doesn't look like I got that in my picture, unfortunately. Hang on a sec. Okay, it actually, that value from the chart, it just didn't come out in the picture, is at 0.08. And so we had 0.3 before, and now we're going to put the second decimal place on it, so it's 0.38 for our z-score. Just double check that it was 0.3, make sure my memory is not failing me. No, 0.6, 0.68. And so if we minimize that again, then we know that we want our p-value, or our z-score in this case, to be 0.68. So when we do our calculation, z is equal to the score, the raw x value, minus the mean, which is 242, divided by the standard deviation, which is the square root of 29. And we know the z-score has to be 0.68 from our chart. And so we end up with this step. And then the last step would be to bring this root 29 over here. We're going to multiply it by the 0.68. And then we're going to bring the 242, it's minus 242 on that side, and we're going to add it onto the answer. And that's going to give us the z-score, or sorry, the x value, the raw x value that you would have to get on this test in order to be in the 75th percentile, or in the top 25% of all of the students. The second question is just asking you to find your standard deviation, and they're giving you the formulas. And this is a sample because there's only 3 values in it, just these 3 values right here, 65, 48, and 70, okay? They're asking us to calculate the standard deviation. And so the sample mean is just adding together those 3 numbers. And so we have 133 plus 70, so that's 203. That's the total of our values. And for a mean, we just take that total and divide by how many numbers we have, which is 3. And so that's going to come out to 63.8 or something like that. I don't have a calculator here in front of me. Okay. So if we're calculating the deviations and the squares from the deviations, then what we're going to do is take that mean score that we just got. So the sample mean, we use the notation x bar for it. And if I was correct in doing that in my head, then the sample mean is 63.8. So the deviation of 65 is just asking you how far that score of 65 is away from the mean. And so that's equal to 1.2. And if we square that deviation, we're going to get 1.44. And the reason we do the squaring is to get rid of any negative values so that we just have the deviation, like just the distance between that number and the mean, and not whether it's above or below. So we do the same thing for 48. We take 48, and here's a perfect example of where we're going to get a negative value for our deviation. And then we're going to square that, whatever negative 15.8 squared is. It's over 200, I know that. And it's going to be a positive value for your deviation. And then for your deviation squared. And then for 70, we're going to do 70 minus 63.8 again. So we're going to end up with 6.2. And here we're going to square 6.2, 36. I can't do that one in my head fast enough, so I'll let you do that as well, okay? Now, I suspect, I don't think I have the rest of this, but I suspect that now they want us to calculate the, up at the top here, it's saying find the sample standard deviation. And so all we have to do now is take the sum of these deviations squared. In other words, we're just going to add these up, whatever they add up to. And when we want to find the SD, we're just going to take the square root of that answer, and that goes on top. And because it's sample, we don't divide by n, we divide by n minus 1. So 3 minus 1, because there were 3 points in our data set, and that's equal to 2. And as soon as we do that division, we'll have a value for the standard deviation. Okay? So if you have other questions before Tuesday, feel free to send them over on email, and I'll make you a video and send it back, and then we can work together in person on Tuesday also.